right, in this video, we're going to be talking about using the point-slope formula to write the equation of a line. Now, the equation of a line in point-slope form through any point called x1, y1 with slope m is y minus y1 equals m times x minus x1. And that comes from manipulating the slope formula, which is y2 minus y1 over x2 minus x1. Now, this is used when we only know one point and we know a slope. And so for the second point, since we don't know it and it could be anything, we just will put in xy for x2, y2. So in this next step here, you can see where I substituted in a y and an x for the y2 and x2. And then you just simply multiply both sides by x minus x sub 1. And so that cancels on this side, and you're left with y minus y1 equals m times x minus x sub 1, and that's how you get your point-slope formula. So now in this problem, it says a line passes through negative 5, 2 with a slope of 3/5. What is an equation of the line? Well, before we've learned that we could write an equation if we know the y-intercept and the slope, but we don't have the y-intercept in the situation. But we have a point, and so we will call that x sub 1, y sub 1, and we have the slope, which is 3/5. So we can use the point-slope formula. So we just substitute in y sub 1, which is 2, and then the slope, which is 3/5, and x minus x sub 1, so minus a minus 5. Two negatives make a positive, so I'll switch that. And then you could leave it in this form. This would be the point-slope form, but I don't care for this form. I would rather the equation be worked out into slope-intercept form because it just gives me a better visual of what that equation is going to be. So I have y minus 2 equals 3/5 x plus 3/5 times 5, we have to distribute, would be 3. So then we add 2 to both sides. And there, plus 5. So the slope then is 3/5, which we knew that, but we can now see the y-intercept would be at 5. All right, in the next problem, we have a point, so that's x sub 1, y sub 1, and we have a slope, which is negative 3. So we will use the point-slope formula to write the equation. So y minus y1. So y minus a minus 1 would be plus 1, and the slope is negative 3, and then x minus 7. So now we will distribute the negative 3 through. So that's negative 3x, and then negative 3 times negative 7 is a positive 21. Watch those negatives there. And so now we will subtract 1 to get the y by itself. And there is the equation of that line. Y equals negative 3x plus 20. All right, the next problem says a line passes through the point 3,2 and the point 5,8. What is an equation of the line in point-slope form? Well, we don't have a slope. However, we do have 2 points this time, and so we can use the slope formula to get the slope. So remember, the slope formula is y2 minus y1 over x2 minus x1. So this is the first point. We'll call it x1, y1. This is the second point. We'll call it x2, y2. So in this case, first, we take y2 minus y1. So that's 8 minus 2. And then x2 minus x1, so that's 5 minus 3. So we get 6 over 2, which is 3. So that's the slope. Now, we have 2 points, and it doesn't matter which one we use. I'm going to show it to you with both so that you can see it won't matter with our outcome. So let's say we choose this for our x1, y1. And we're going to use a slope of 3. So we would have y minus y1 equals 3 times x minus x1. And if we distribute, we'd have y minus 2 equals 3x minus 9. Add 2 to both sides. We have y equals 3x minus 7 for the equation of the line. Now let's say that we would have said, oh, but let's use this one for the x1, y1 for the point that we use. So then we would have y minus y1, which is 8, equals 3 times x minus x1, which is 5. Now if we distribute, we have 3x minus 15. And you'll see we get the same answer. Y equals 3x minus 7. So once you know the slope, you can just pick one of the points, use the slope, and then the point-slope formula will give you your equation. And then we're also going to be talking about standard form of a linear equation. That is ax plus by equals c. So now the difference between standard form and slope-intercept form is with standard form, the x and the y are on the same side of the equation. And typically we want the a and the b, which are the coefficients of x and y, and even the c to be integers. Now, we're also going to talk about the graph of a line, and this will lead us into graphing when equations are in standard form. But one thing I want you to notice, this line has a y-intercept at 2, or at the point over 0 up 2. And so notice at this point, the value of x is 0. So at the y-intercept, x is equal to 0. And now if we look at the x-intercept, so where the line crosses or intersects the x-axis, the value of y here is 0. So we go over 4, up 0. And so at the x-intercept, y is equal to 0. So we have to remember that at the y-intercept, the x value is 0, and at the x-intercept, the y value is 0. So when we look at this next equation that is in standard form, if we have to graph it, we can do that fairly easily by finding the intercepts. So for the x-intercept, remember we said y equals 0. So like if we were making an xy chart, y is equal to 0, and we have to figure out what x would be. So what we're going to do is substitute in a 0 for the y. Now, 5 times 0 is 0, so this just cancels out. And so then x is equal to 5. So when y is 0, x is 5. So your x-intercept, so we'll go to the x-axis, is 5. And now for the y-intercept, remember we said x is equal to 0. So we'll substitute in a 0 for the x. And 3 times 0 is 0. So we have 5y equals 15. So y is equal to 3. So when x is 0, y is 3. So the y-intercept on the y-axis is 3. And now you have 2 points, and through any 2 points you can draw a line. And that is going to be the line for that equation. We'll do one more real quick here. So the x-intercept, and we'll shorten it up a little bit, we know that y is equal to 0. So you have 2x equals 8. So x would equal 4. So the x-intercept is 4. So we go to the x-axis, go over to 4, y is 0. There we go. There's the x-intercept. Let me erase real quick here. And at the y-intercept, x is 0. So we have negative 4y equals 8. Divide by negative 4, y equals a negative 2. So on the y-intercept, when x is 0, y is a negative 2. And there we have our x and y intercept, and so you can draw the line. All right, the next problem is not in standard form, but we use the same rules apply. At the x-intercept, y is 0. At the y-intercept, x is 0. So let's just go ahead to find the x-intercept. We know that y equals 0, so we'll substitute 0 in for y and solve the equation. you have 3x equals 9. So x equals 3. So the x-intercept in this case is 3, and the y-intercept, x equals 0, and so we'll substitute in a 0 for the x. So y then is equal to a negative 9. So the y-intercept is at negative 9. So if we were going to graph those, I'll do it in a different color here. X is 3, and y is negative 9. And when I say 3, I mean the location is 3, 0, and this is at 0, negative 9, and then you can graph that line with those intercepts. All right, now we have a word problem. The number of times a cricket chirps per minute depends on the temperature. The number of chirps in 2 seconds for 2 temperatures are shown at the bottom right. What graph models the situation? Well, we have at 40 degrees, there were 0 chirps, and at 93 degrees, there were 8 chirps. So we can write it as 40, 0, and 93, 8. So our inputs will be the temperature, and our outputs will be the chirps. So the y values will be the chirps. And looks like those we can count by ones there when we plot those values. And the temperatures, we better count by tens to flip that on our graph. And this is the temperature. All right, so let's plot those points. So when it was 40 degrees, there were 0 chirps. And when it was 93 degrees, there were 8. So we'll go up to 8 right about here. It would be somewhere in there. So we're kind of ballparking it here. And then we want to draw a nice straight line. So I'll use the tool to do that. There we go. Somewhere in there. And then that would be the graph that would model the situation. So if we look at C, it says if the temperature is 7 degrees, how many times would a cricket be expected to chirp in a minute? So if we look at our graph at 70 degrees, we can kind of get an idea. Oh, it's somewhere a little more than 4.5, between 4.5 and 5. But if we wanted to know exactly what it is at 70 degrees, we could write the equation of the line and substitute 70 in for the x value, our input value. And to write the equation of the line, we can first find the slope, and then we will use the point slope formula. So the slope will be, we have to subtract the y's, so it would be 8 minus 0 over the difference of the x's, which would be 93 minus 40, so y2 minus y1 over x2 minus x1. So that is 8 over 53. So some messy numbers to work with a little bit, looks like. So now we will use the point slope formula, and let's use this for our point, our x1, y1. So we have y minus y1 equals m times x minus x1. So now let's substitute in our values here. So y minus y1 equals 8 over 53 times x minus 40. So that would be 8 over 53x, and I'm going to grab my calculator for this one. Eight over 53 times 40 would be 320 over 53. And there's the equation of our line. And so in the part C where it says if the temperature is 70, how many times would a cricket be expected to chirp in 1 minute? So we can substitute 70 in for the input. So the x values would be the temperature, so we'll put 70 in for x. And when we substitute that in and punch it out, 8 over 53 times 70 minus 320 over 53 we get 4 and 28 over 53, so about 4.5 is our answer there, which is about what we approximated here when we looked. All right, just a real quick review here. The slopes of parallel lines are equal. They're changing at the same exact rate, and the slopes of perpendicular lines are negative reciprocals of each other. So if the slope of this line were 2, the slope of this line would also be 2. If the slope of this line were 1/5, the slope of this line would be the opposite sign, so negative, and the reciprocal of 1/5 is 5/1. So the next problem says, what is the equation of each line in slope-intercept form? So we want to write the equation of the line parallel to y equals 6x minus 2 that goes through the point 1, negative 3. Well, we're going to go through the point 1, negative 3, and we want to be parallel to this line. So remember, lines that are parallel have the same slope. So the slope will be 6. Now, after that, we don't need this equation anymore. We're making a new one. So we'll use the point slope formula. Y minus a minus 3 equals 6 times x minus 1. And we distribute. So y equals 6x minus 9 is the equation. And if you graph both of those lines, you should see that they are parallel. The next problem, we want to write the equation of the line that is perpendicular to y equals minus 4x plus 2/3 that goes through the point 8, 5. So we have a line that's going through 8, 5, and it's perpendicular to this other line. Well, this line has a slope of negative 4, so a line that's perpendicular would be the opposite sign, so it's positive. And then the reciprocal of 4, which is 4/1, so the reciprocal is 1/4. Now we'll use the point slope formula. So y minus 5 equals 1/4 times x minus 8. And we distribute. And then 1/4 of 8 is 2. And then we'll just add 5, and we have it. So y equals 1/4 x plus 3. All right, there are just a couple other examples here. In this problem, it says we want to write the equation of the line that's parallel to this 4x plus 2y equals 7 that passes through the point 4, negative 2. Well, we know it goes through the point 4, negative 2. And if it's parallel, it has the same slope, but this equation is not in slope-intercept form. So before we can work with this, we need to solve for y here to get this in slope-intercept form. And then we divide by 2. So this equation then in slope-intercept form is negative 2x plus, it would be 3.5 for the y-intercept. So the slope of this is negative 2, so a line that's parallel will have a slope of negative 2. And now you can use the point slope formula to write the equation. In the next problem, it says, what is the equation of the line perpendicular y equals 2/3 x minus 1 that passes through the point 0, 6? And so the slope then of the line that's perpendicular would be the opposite sign. So it would be a negative, and instead of 2/3, it would be 3/2. And then put negative 3/2 as a slope and 0, 6 in to the point slope formula, and you can get the equation for that new line. And that's it for this lesson. So let me know if you have questions. Thanks for listening.